Okay, hi everybody. I just wanted to do a quick video about a problem that we didn't get to do in class today during the review session. And here it is. It's these last two problems from chapter 20 problem set, number 35 and number 36. These problems are very closely related. In fact, they're just the reverse of each other. What is missing in here is a really important equation, and that's this equation right here. So don't worry, I will definitely give it to you on the test. This is the equation that you derived while you were doing the electrochem virtual lab. And that is the relationship between time and current to the coulombs, the charge. Q here represents coulombs, which is a unit of charge. I represents the current, which is measured in amps, and T represents time, and the time here is in seconds. That's important to know because sometimes a problem will be given to you in minutes, or it might ask you an answer in minutes. But the formula itself, which will be given to you, uses seconds as time, so don't forget that. The other piece of information you know was given to you, and that is the value of this constant F, which is Faraday's constant, and it tells me what is the charge in units of coulombs for 1 mole of electrons. It's a constant value, and there's several formulas that have Faraday's constant in them. We aren't using those formulas to do either of those problems. We are just using the value of F to do our calculation. But we will need this formula, which was not given to you, which is why I want to make this video for you now. Okay, so let's start by looking at problem 35. Problem 35 says, how many grams of copper are obtained by passing a current of 12 amps through a solution of copper sulfate? I know that's a little bit pixely there, but that's CuSO4, copper 2 sulfate, for 15 minutes. And when you look at the information you have here, if you label this, you can see that this is time and that this is I. So I have two variables from this equation, but I'm not being asked for coulombs. I'm not being asked for charge. I'm being asked for grams. Okay, so I have to do a two-step process. First, I'm going to use this equation, Q equals I times T. Then I'm going to take my coulombs and I'm going to use them along with Faraday's constant to get me moles of electrons, and that I'm going to convert into grams of copper. So it's a multi-step process. Okay, so step one is to use the equation that's given to solve for Q. So Q equals IT, Q equals I times T, which is to say that Q equals 12 amps times 15 minutes, but remember it has to be in seconds. So to convert 15 minutes to seconds, I say 15 times 60, because there's 60 minutes in each, 60 seconds in each minute. So 15 times 60 converts my time into seconds. Right, so when you plug in those values into the formula, 15 times 60 is 900, 900 times 12 is 10,800, and the units on that, because we're solving for Q, the units on that are coulombs. You can go through and figure that out yourself if you look up what amps are equal to, and when you multiply amps times seconds, you end up with coulombs. But you don't need to know that. Just know that when you're solving for Q, the answer is in coulombs. Now, I can take this number and I can do some math with this constant up here. This value, 96,485, is the number of coulombs per 1 mole of electrons. So all these reactions involve the movement of electrons. And what this says is 1 mole of electrons has a charge of 96,485 coulombs. Well, I've got a number of coulombs here. It's not nearly this number, but it's about 10% of that number, a little bit more. So I can figure out, using this number and this number, how many moles of electrons I have. The way I have to do that, if you look at the units, is I have to divide my coulombs by this number, because this is 96,485 coulombs over 1 mole of electrons. So we're going to we're going to flip that, and we're going to say 1 mole of electrons over 96,485. That's going to be a conversion factor that I multiply by my coulombs. So when you set it up like this, you've got your value for Faraday's constant, but we flipped it over so that the coulombs will cancel. So what you're doing in your calculator is taking 10,800, dividing it by 96,485, but this is the reason why you're doing that. You're really multiplying this number by this conversion factor so that you end up with moles of electrons. And you end up with a weird looking number. I put all the sig figs because it's not the end of our calculation, but a small fraction of moles of electrons is what you end up. That's okay. Moles are huge, so it's okay to end up with a small number of moles of electrons. The question now is, I've got moles of electrons. The problem wants grams of copper. So how can I turn moles of electrons into grams of copper? And the way we're going to do this is with stoichiometry, good old-fashioned stoichiometry, but we need an equation to do it. So to make sense of this, you have to think about what's happening. According to the problem, I am passing a current through a solution of CuSO4. A solution of CuSO4 means that it's not solid CuSO4. It means it's been dissolved. It means it's broken down into the ions that make up this ionic compound. That's copper 2 plus and sulfate 2 minus. That's the source of the copper that comes out at the end of this process. This copper, this is neutral copper, this is copper atoms, copper metal that we're familiar with. This copper with a +2 charge, these are copper ions, and in solution they usually look blue. So this would be looks like blue colored water. And so what's happening in this process is these ions are being turned into these atoms. These charged ions are being turned into these neutral atoms. So how is that happening? It's happening through electrochemistry. It's a redox process. What's happening is these copper ions are going from a 2 plus charge to a charge of 0, meaning they're gaining electrons. And how many electrons are they gaining? 2. So I can write a little chemical equation to show that process. Here I see my copper 2 plus ions adding 2 electrons to become neutral copper atoms. And what that gives me is a stoichiometric relationship. Then I can say, okay, right now I have information about moles of electrons. What I want is grams of copper. Well, I can look at this equation and I have a ratio between moles of electrons and moles of copper atoms. For every 2 moles of electrons, I can produce 1 mole of copper atoms. Once I get to moles of copper, then you guys know it's super easy to turn moles of something into grams of something, and that will be the end of the problem. So let's set that up. So the setup now is going to look something like this. I take my moles of electrons, and I just round it down to 3 sig figs because this number is too long to fit up here. So I've got my moles of electrons from all of this work over here. I'm going to multiply it by a mole-to-mole ratio with moles of electrons from the bottom, 2 moles of electrons from the equation, to 1 mole of copper, which is the substance I'm interested in the top. My final units have to be grams of copper, so I need another conversion factor that gives me moles of copper into grams of copper. That, of course, just comes from the periodic table. I put the 1 mole of copper in the denominator so it can cancel out here, and that's going to leave me, after everything cancels out, moles of electron, moles of copper, then I'm going to be left with grams of copper, which is what my final answer needs to be. So when you do all that math, you just divide 0.112 by 2, then you get that answer, multiply it by 63.54, and you should get a number something like 3.56, and this happens to be multiple choice, and you can look quickly, there's one there that is correct, and I'm pretty sure if you look at the end that B is the correct answer. Notice that if you got the mole ratio of the electrons wrong, like if you didn't know it was 2 electrons, then you would end up with a number like C, okay, because you wouldn't be dividing by 2, so your final number would be about twice as big, so something like 7.1, 7.2. The way that I knew this part is I really have to understand the substance that I'm dealing with. What does it break apart when it's in water? So you have to do a little bit of detective work. You have to search your memory a little bit to know, oh yeah, this breaks apart into ions and the charges are +2 and -2. If you don't know that, then just make a guess and just go for it. And then as long as you do the whole rest of the process correct, you'll only lose like half a point or something. But it's obviously better if you know it like this. Okay, recap. Here are the steps for this problem. First thing we did was we found Q by using Q equals I times T. Second thing we did was to use the value of Faraday's constant to find how many moles of electrons there were. And that's what we did over here. This was finding Q, 10,800 coulombs. Then we divided it by the value of Faraday's constant, and that gave us the moles of electrons. We used this number to do some stoichiometry, and we used the relationship between moles of electrons and moles of copper, which is what we were asked about, and then we converted those moles of copper into grams. So find Q, use F to find moles of electrons, use moles of electrons to find moles of copper, and then if the problem asks you to convert it to grams, then convert it to grams. Now, having said all that, this problem is the exact opposite of that. Here I'm given grams of silver metal. That was like our endpoint of our problem, grams of copper. So here I'm given grams of silver metal, and I'm given the solution, and I'm given the current, and what I'm asked to find is the time. So you can see we're going to be going backwards, okay? You're going to take your grams of silver metal, turn those into moles of silver metal, use that to find moles of electrons, then use F to convert the moles of electrons into Q, which is coulombs, and then you'll have Q, and you're given I, which is the current in amps, and then you use those together to find T, which would be in seconds. So see if you can do that one backwards. The answers are there. I'm not going to make the video for that part because I think you should just be able to do the reverse of what we did here. Okay, good luck.